Well, hello everyone, and welcome to today's webinar, ESD Control Made Simple, Practical Insights for Building a Successful ESD Workstation. My name is Carissa Harris, U.S. Marketing Director for Treston, and I'll be your moderator today. I'm joining you from the Treston showroom in Canton, Georgia. You'll see I have several Treston ESD workstations set up behind me. Today I'm joined by 4 experts with deep experience in ESD control, workstation design, and real-world implementation. We have Greg Heckler from Desco Industries, Henry Salgado from Static Control Solutions, Neil Cottle from Treston, and Bill Butt from Quantum Systems. Together, they'll cover ESD fundamentals, workstation components, design considerations, common setup mistakes, and practical best practices for building a successful ESD workstation. I'm excited to have all of them joining us today. So just some general housekeeping notes before we begin. Today's presentation is being recorded, and the recording will be sent to you after the webinar. Your microphones and cameras are turned off. If you have questions during the webinar, please submit them through the Q&A panel, and we'll answer as many as we can get to during the live Q&A at the end. And of course, if anything comes up during the webinar that we don't get to, please reach out after the webinar, and we're happy to help. So today's session is designed to be practical. We'll briefly touch on foundational ESD concepts to set context, but the main focus of this discussion is effective ESD control in practice, specifically how the workstation fits into and supports a complete ESD program. Greg and Henry will begin by walking through the fundamentals and major components of an ESD workstation. They'll also use live examples from the SCS showroom to show how those components work in practice. Then we'll shift from the ESD control products to the workstation itself. Neil and Bill will talk through how workstation design affects grounding, storage, ionization, operator workflow, and long-term compliance. We'll also discuss best practices for setting up ESD workstations, where common setup mistakes happen, and what to consider when evaluating the right solution for your application. But before we begin, let's start with a quick poll. So please take a moment to answer the poll on your screen. How would you describe your current ESD program? I'm going to give everyone just a moment to respond. All right. Thank you. That mix is helpful, and it reinforces why we built today's webinar this way. Some of you may already have a full ESD program in place, while others may be evaluating options or starting to build one. So either way, the workstation plays a major role in how those controls are actually used every day. So Greg and Henry, I'm going to hand it over to you to get us started.
Thanks, Carissa. Greatly appreciate it. And thank you, everybody, for joining us today. We've got quite a bit of information to go through for those of you that don't know who we are. So I'm Henry, and that's Greg. So you're gonna get quite a bit of us today. So I'm gonna get out of the frame here and leave Greg in there so you guys can focus on him. We're going to keep this first section brief because many of you already know what ESD is and why it's so important and why it matters. But it's very important to establish a shared foundation before we talk about workstation design. So static charges are created when two surfaces of similar or dissimilar materials contact and separate. So one surface will become positively charged and the other will be negative. So ESD is also a function of a charged conductor touching another conductor.
Right. Thanks, Henry. And hello, everybody. And for those of you out there that we already know, thank you for coming. We really appreciate that. So what I have here is I have this acrylic, just pure acrylic paddle here. I've got another acrylic, what we call paddles, with a solid piece of aluminum. So this represents what we would call insulators or static generators. They could be the fiberglass PCB itself. It could be a connector. It could be, let's say you have a Samsung cell phone. The case of a Samsung cell phone is plastic. It's an insulator. So those are the things that generate the charges and the greatest charges out there. This represents an isolated conductor, or you not grounded, wearing your wrist strap, or let's say the IC sitting upside down on the workstation with the leads facing the air. So the way we generate static electricity, and I've also got what we call a static field meter here. Hopefully you can see that there, getting out of the light. There we go, Henry. Thank you. This static sensor, static field meter. So this measures static charges or static fields, if you will. So with contact and separation, whether you're walking across the floor or you open a plastic bag, we can show you. Can you see that there, Henry?
Mm-hmm.
What I got there?
5,000, 6,000 volts.
5,000 volts. But now I bring that isolated conductor in there. What I have about 3,000 volts. So you can see obviously that the insulators charge up greater. However, you'll see that this one's positive, and you may see a minus sign there on the left. This one is negative. Each one of these is a static charge of a different polarity, and each of those polarities can cause damage. Now, the big difference here is we have a workstation here with a grounded static dissipative mat on it. So I'm gonna show you this charge again real quick. Now I'm going to say, okay, I'm going to set my plastic case on here, and I'm going to ground that charge. Did I ground that charge, Henry?
No.
No, right. So now I'm going to take my conductive paddle, and let me show you the charge here. Okay. Now I'm going to ground that conductive paddle or my board or my IC. Did I knock that charge down, Henry? Okay. So you can ground conductors. You cannot ground insulators. So one of the goals of the workstation, we'll talk a little bit more, is whatever things that you have on it conductive, whether it's a conductive bin sitting up on one of your rails, whatever it is, a tote box like this, the bag, the board sitting on the thing, we want to keep all those conductors at equal potential. Okay, Henry?
That's right. And one other thing that's very important to remember is the amount of time, friction, and humidity all contribute to how large the charges will become.
That's right. The lower the humidity, the bigger the charge, the greater the humidity, the lower the charge. So that's why in summertime, like right now, we don't get shocked a lot because that humidity is keeping that potential off our body or keeping it lower. In the wintertime, especially in places like Minnesota, Arizona, etc., real dry, we're going to get shocked a lot, and hence we're going to have more of an ESD threat at those times of year.
Right. And speaking of which, electrostatic discharge, ESD, is a sudden transfer of an electrical charge between two objects at different potential, right?
Correct. So let's say this insulator, I got 5,000 volts on it. Now, that's not an ESD event yet. It can be damaging when it induces this positive charge on that negative polarity of the IC. That's one way. Another way is when we touch another conductor of an opposite polarity. So your body is conductive. You're wet on the inside and dry on the outside. When you sweat, okay, that sweat layer makes you conductive. It's salts, minerals, things like that in your perspiration. And so when you walk across that carpet, you're going to charge up positive about 99% of the time. When you go over and touch that doorknob and you get a shock, that's because that metal doorknob is a negative. So that's another way that we create an ESD event. Also, just so you know, it's very important to understand, and this confuses a lot of people. The only time you can have these significant events is when one charged conductor touches another conductor. So me touching the doorknob, or what we call an HBM event, I walk over with a charge on my finger and I touch the lead of that IC. That IC is not only conductive, but it's a lot more, it's a great or lower potential than I am. It's much more conductive than I am. My body's about 500,000 ohms, that lead's 0 ohms. So that's how we create events in general. So on this slide here, as you can see, I mentioned the term HBM, the human body model event. That's the top right picture. That's a guy hitting that IC with about 7,000, 8,000 volts, and then the resulting damage, for example, down on those other pictures. Basically what we do when we send that great amount of energy through that, we melt the oxide layers inside the semiconductor, like a lightning bolt blowing a tree in half or blowing a hole in the ground. So that's what an ESD event is.
Yeah, and both of those failures can both be costly, right?
Right. Well, obviously, if you hit your device with an HBM event and it fails, it's dead. So it's going to cost you the time and money to replace that IC. It costs you all that time to build the board, for example. All right. And so, but that's a good event. This one's not leaving the door. It's the CDM events that we have a problem with.
Right.
Go ahead, and I'll explain that in a second.
No, that's exactly right. That's kind of what we're getting into because the challenge is that many of these electronic components can be damaged by voltage levels that are way far below that a person can feel, right?
Right. Yeah. In fact, it takes about 2,000 to 3,000 volts before your body feels it. So that one of the problems is you can go throughout your day not getting shocked, but you're still generating charges in excess of what the class of the device is. So if this was a 500 volt processor on here and I'm generating 1,500 volts, I'm not feeling it, but I can zap it all day long and not know I did it. And then the other problem is that when we charge conductors up and then ground them like pulling an IC off a reel on a pick and place machine, comes over, has a charge on it, sets it down on the trace or the pad of that device, zap. That's what we call CDM events. Those are events that where we have conductors charged by these insulators on my workstation. Those usually create a partial damage or a latent defect. That's where the costs come in. You don't detect that in your test department. It goes to your customer and later on fails. That's much more, 10 times or more costly than the HBM event.
Exactly. All right, so let's talk about ESD control being a system, Greg. So ESD control cannot be viewed as a single product or a single step. A wrist strap alone isn't enough. A mat alone isn't enough. A workstation alone isn't enough. An effective ESD control program is a system. It includes people who handle the product, the workstation they use, the work surface, grounding, storage carts, racks, packaging, flooring, testing, verification, training, and written procedures. Each element has to support the other. When one piece of the system is missing or not maintained or not understood, the risk increases.
Correct. So most of you, I'm sure, are familiar with our industry standard called ANSI ESD S20.20. And that standard's made up of multiple components, but it is based on keeping the human body from generating more than 100 volts. That's where the wrist strap comes in. Or the ESD footwear, for example. You plug, I have one over here. We're going to talk about monitors in a minute. But if I have my body grounded through my wrist strap here, I'm not going to generate more than 100 volts. But there's a whole bunch of other aspects. There's the assembly process. You want to snap that back on for me, Henry? There's assembly processes. There's the workstation surface. There's carts. There's all kinds of different things that are ways that your product is being handled, whether it starts at the stock room or it's on a workstation like this in an assembly area. So in that standard, there's multiple what we call technical requirements. A technical requirement is the work surface. It may be the cart over here, the mobile workstation. It could be packaging materials like the bin that your components are setting in. There's all different kinds of components. There are tools. So not only is the tool conductive, but the grips are static dissipative. So there's other things, your chemical dispenser. So there's a whole bunch to think about when it comes to a system for static control. By the way, a wrist strap is not the band only. A wrist strap is the band and the cord, and then it's tested with you in that system. So you're not just measuring the wrist strap, you're making sure your human body is grounded properly. So that's how this wheel that you're seeing here, multiple components from flooring to ionization, all those combine to make 100% of a static control program. So that's the important thing. So all of these things are based on how sensitive that device is. And today we have components that are less than 10 volts or even less than that now. We call them class 0 devices. So depending upon what it is that you do, military, aerospace, med device, whatever it is, it's all based on how sensitive that component is.
That's right. And a big part of that is identifying the EPA, right?
Correct.
The protected area.
Correct. So it usually starts at receiving. How are you getting your devices in? Are you using a contract manufacturer to purchase pre-assembled PCBAs? Are they coming in static shielding bags, etc.? How are they going from there to the stock room? How they're being stored? From the stock room, are they being kitted and taken to my workstation? Are they going across the floor on a cart? So all of those things need to be taken into consideration. And we have this nice little graph to help you, or remind you of all the things that need to take place. Awareness is very important. This is our awareness floor tape, for example. So one of the requirements of the ESD standards is that you identify your EPA or electrostatic protected area. And that doesn't mean just putting this on the floor or a sign on the wall.
Like over
That
your
means,
shoulder.
that means, or like this, right? That means documenting. This is like, for instance, we call it our CA1 lab here, where we build this board for our tester, for example. That's identified by signs on the doors, the wall, but it's in our written plan that says CA1 lab is an EPA.
Very good. So, okay, so we're going to move on and talk about practical concepts we'll build on. So there's a few practical concepts that we'll return and go through this webinar. First, the 12-inch rule. In general, items within roughly 12 inches of an ESD sensitive device need to be considered. Insulative or high charging items that are close to the product can create risk.
Right. So that's all about controlling these insulators, right? So let me give you an idea what that 12-inch rule means. So I've got about can you see that, Henry? Sorry.
Yeah, it's about 5,000 volts.
Okay, about 5,000 volts. When I pull that back more than 12 inches, for example, now I got almost nothing, right? Okay. So sometimes ESD control is just practical. Get this thing out of the way. No water bottles, no, coffee, styrofoam coffee cups, etc. Just get rid of it. If it's required to be there, but not necessary to be right here, put it at the back of the bench, whatever it takes. Or maybe I buy this an ESD protective paddle. I could do that. Or if it's what we call process essential, meaning I have to put this screen right near my static sensitive device, I need to assemble that board under ionization or with some type of ionizer.
Mm-hmm.
So that's how we control, that's where the rules come in.
Correct.
So they're your friend, just move it if I don't need it over here.
Just get rid of it. Right. Exactly. So second, we're going to talk about storage. Storage matters. Grounded shelving is often overlooked, but operators frequently place ESD sensitive items on shelves during the work process.
Okay. Yeah. So for example, from a bench standpoint, I don't have one of those here, but there's examples that Carissa's going to be talking about, rear bench shelving. This is very common, right? The conductive bin box. Okay. And so maybe you're clipping those on the back of their shelf. So there's two things to understand about packaging. One is that they at least be dissipative and or conductive, but two, all conductors need to be grounded, whether it's the IC on the component, whether it's the hand tool when I'm holding it, whatever it is. When I clip this on, this needs to be conductive. Otherwise, it's an isolated conductor like that metal paddle. So that's something to keep on. It's also important that we have a properly grounded ESD work surface. If I set this tote box in here full of boards, now I'm grounding that tote box. And consequently, anything touching that, components, they're grounded as well. So the packaging system doesn't end at the stock room. It travels all the way throughout your process. And most importantly, as well, is it's not always about what's in the box, it's where it's going. So I still need one of these, even if it's got nuts and bolts on it, if I'm going to set that right next to my board and take these components out or plastic connectors, whatever they are. So think about it that way as well. Not just what's in it, but where it's going.
That's right. And you touched on the third concept that we're going to talk about, Greg, and that's the work surface. Now, sometimes mats make sense, whether it's a rubber mat, a vinyl mat, 2-layer, 3-layer vinyl, or laminate, right?
Yes. So ESD protective laminates are readily available. I know Treston sells a really good ESD material. This one isn't, but you would know that. Obviously, you would specify that for your workstation. So that's one way we can create a grounded work surface at our environment or on our bench. The other way are with soft matting materials. Maybe I want something that's softer to work on. I want different chemical resistance, temperature control, things like that. Even if I've got an ESD laminate, I might want something that is going to, stand up to abrasion. I've got heavy things, whatever the reasons are. There's a lot of applications for soft mat. I might want to cover up my conductive metal cart with an ESD work surface material to make sure I don't have CDM issues. So the way that a good laminate works and the way that good soft materials work is they have ground planes in them. So on this mat right here is the random rubber, 2-layer rubber mat. The outer surface is dissipative. So when I set a device on here with a charge on it, it properly dissipates that charge away. The bottom layer is a conductive layer. When it goes through the top layer, it gets to that conductive layer, then it speeds off to ground and it's gone. Same thing with a good quality laminate. The color surface is dissipative, and right underneath that surface is a conductive scrim. It's about 3 mils thick or so. So when that charge goes through the laminate, it goes through that scrim, off the ground cord, and gone. Most importantly, though, when you use good materials like this as well, and laminates, is that makes them compatible with your continuous monitors. So that's something that's really important if you're using monitors.
Exactly. And we're going to touch on that a little bit in just a few minutes when we start talking about the components of an effective ESD workstation. We'll get a little more in detail. But finally, the last is ionization. Ionization becomes important when insulative materials cannot realistically be removed from the work area. So we've got an ionizer here set up that Greg's going to show you. So keep all of this in mind. We're going to get further deep into this. But again, to summarize this section, ESD control is a system, and the workstation is where many parts of that system come together.
Right. So if you are using what we call process essential insulators, remember we discussed that, things that have to be used. Those are connectors, your product enclosure, things like that, other components that are close by. Like one of our continuous monitors, we use a speaker in there. So when the monitor alarms, you can hear an alarm. Well, that thing generates 3,000 or 4,000 volts. So that would be something that I need an ionizer to neutralize. The way ionizers work, if you look at this picture on your right here, is they artificially generate positive and negative ions. So if that screen had a positive charge on it, the negative ions attack that and they neutralize that opposite polarity. And the way they get those ions to the product is through fans in the ionizer. So whether it's a single fan benchtop or a multiple fan overhead, that's the way we control process required insulators.
Excellent. Thanks, Greg. Okay, Carissa, we're going to send it back to you for just a moment.
Yeah, so thank you guys. That gives us a really good, strong foundation to ESD control. So now that we've established why it has to be treated as a system, let's look at the workstation components that support that system. So I'll turn it back over to you and you can walk us through those major components.
Perfect. Thank you so much. So just want to make sure everybody is still with us. So if you got to get up and walk around or move around a little bit, go ahead and do that. So what we're going to talk about now is when someone is designing an ESD workstation, I always recommend starting with the work, not the accessory list. Okay, first of all, what's being handled? Second of all, how sensitive is the product? That's key, right, Greg?
Absolutely.
We've got to understand what your most sensitive component is, correct?
Yeah.
And the other is, what does the operator touch? Where are these parts stored? What tools or materials need to be within reach? So once we understand the process, the workstation components make a lot more sense. Each component has a job and each one support the other.
Correct. And it all goes back to those technical requirements. Once we have all of them, we've completed that system. We don't have charge generation. If we have charges, we're properly dissipating them, etc. So again, how am I getting the products there? I talked about the packaging aspect of it, but I want to touch on something that's one of the most important parts of your static control program in general, and that is grounding. And so you want to make sure that when you're setting up your workstations, purchasing them new, whatever, they've got good ways to achieve grounding of the workstation surface or the work surface, what we call common point grounding. We don't want to have multiple grounds go to different places. We want one location where all our grounds go to, whether that's a bus or a grounding mechanism like this that monitors the safety of your ground, things like that. Okay, you want to go?
No, go ahead.
Oh,
we're going to get into that in just
we want to make sure we're testing our ground and whatever. So that's also very important when you're choosing your workstation, is how is all this stuff going to get grounded? I talked about this bin box, okay? A lot of people will just go clip this on their powder coated rail. Well, that's not grounding it. You're gonna have to chip the powder coating off in order to get to the conductor. So can I buy a bench with a properly groundable rail system, that type of thing? So Carissa will touch on that as well.
That's right. So you're already on the subject, so we're going to keep rolling on that. So the work surface. So the work surface is where most people usually start. So if you're building a bench, the first thing you're going to probably think about, right, is am I going to use laminate? Am I going to use a work surface mat? So an ESD work surface provides a controlled path for static charges to dissipate safely. So it's not about draining the charge as fast as possible. You touched on that a little bit already, Greg. It's about controlling the path at a rate of dissipation in a way that protects sensitive components. If the workstation has a properly grounded ESD laminate surface, the work surface itself is part of the ESD system.
Correct. So many of you have, obviously, out there building electronics now, probably everybody's got some type of work surface. Now, this is a good picture for illustration for talking about that buried scrim that I was talking about. So one of the ways that you could tell that if you have a ESD laminate now on your existing workstation is on the picture on the right, you see that little ground bolt going through there. Well, that ground bolt's designed to go through that laminate and contact that buried conductive surface. And that's what's grounding your laminate. It's the same thing with a soft mat, for example. I got this one connected to a continuous monitor, but we use snaps and ground cords, for instance, on a soft mat material. And if you have a 3-layer material, a 3-layer vinyl material, you'll see that you can barely see it, but underneath the surface, there's that dark gray line. That's the buried conductor in the 3-layer material. And we need to make contact with that. And the way we do that is with these snaps that have what we call a push and clench snap teeth. So they bite through that and make contact with that surface that's necessary. And so one of the things Henry touched on or pointed out is the rate of dissipation. So many of you have heard or know of already that there is a recommendation in the standard that the work surface resistance start out at about 1 megohm, 1 times 10 to the 6th, and up to less than 10 to the 9th or a gigohm. The reason for that is I wouldn't want to bring a charge component over to my stainless steel top and set it on there with a charge. That's like you touching the doorknob. So the work surface acts, an important function of the work surface is controlling how fast we get rid of that charge. And when we're in a certain resistance range, we'll dissipate the charge, but we'll do it completely to ground without zapping the device.
Exactly. So speaking of ground, let's talk about common point ground. So common point ground, it may be small, but it's one of the most important pieces of the workstation. The common point ground acts as a central connection point. It helps the operator, work surface, and mat when it's used, and other grounding elements, bring them together so they share a common electrical reference.
Right. So this is, so for one thing, the preferred ground of the ESD Association is your building ground, is your equipment ground or electrical ground, the AC ground. That's on a receptacle. That's the mouth of the smiley face on there, if you will, or a metal junction box. So in this picture on the left here, we see that this bus bar, that is grounded back to the equipment ground. The equipment ground is, let's call it your ESD ground. That's the main ground where everything gets grounded to. What we don't want to have is things grounded at the work area in a bunch of different places. So that's why we have that common point ground. So everything is equal potential. It could be a piece of electronic test equipment. It could be your computer there. It could be multiple things, but we all want those going back to that common point ground. And this is a little device. We make multiple different types, but this has a banana plug on it here. And then it's got multiple places where you could screw on what we call ring terminals on ground cords too. So you can use a bus system like that, things like this. This particular item back here also checks the polarity of your circuit. That's a requirement of the standard and provides all those locations. So you want to make sure that you have good common point ground.
Well said, Greg, well said. Next, we're going to talk about personnel grounding, which is one of the most, if not the most important elements of an ESD control program, because people are often the largest source of static generation.
Right. Well, that's the basis of the entire standard. Is the whole standard was written around keeping the body less than 100 volts. And that's what makes it a universal standard. It doesn't matter whether this is the board out of my tester right here, or it's a military device, an aerospace component, whatever it is, static doesn't know what the thing is. So it's all about, to start with, keeping the human body under 100 volts. And the way we do that primarily is by wearing a wrist strap. Secondary, if you're mobile, by having a footwear flooring system with an ESD floor. And right now I'm wearing foot runners too. So I'm standing on an anti-fatigue conductive mat. We do it that way. But again, it's the same, keeping us at equal potential or at a common point to our workstation.
That's right. And moving on to the continuous monitor side of it. So if you're grounded to a ground port here, right? But the ground becomes disconnected in the back. Are you going to know about it, Greg, right away?
No, maybe 24 hours later. So when you, at a typical electronics manufacturing company, they either do what we call touch testing, or we walk over the wall. In fact, I got one right here. Here's a classic integrated checker, or sometimes we call these touch testers. I walk over, I plug my wrist strap in, I press the button, I get a green light, write my name down that I passed, and I go to work. The problem with that is that, one, it's a total trust thing, right? You're going to assume that somebody's writing pass on there and they're going to work. And then you're probably not going to test again until you come in the next morning or 24 hours later. The popularity of continuous monitoring is that it allows you to be continuously monitored. You're always grounded and you're always being checked. And there's different styles and types, but this is one of them. So you can see that I'm wearing my wrist strap right now. I can assume you might not see green, but you're seeing bright lights here on our monitor. So if I were to fail, okay, let's say my cord breaks, I get an audible and I get that flashing red. And you can see how fast that was. Keep in mind that ESD events happen in about a nanosecond. So there's no way, if you had an ESD or gonna produce an ESD event, you're not going to go, uh-oh, and pull your finger back. You're way too late. In fact, when you touch that doorknob, often you're not even touching it before that event transfers to that doorknob. So these are an integral part of ESD workstations now, because these classes of the device are so low. We're talking 5, 10, 25 volt, 200 volt devices, that type of thing. And that's something that's very popular now. And then another function of that, when it comes to the work surface, is now I can continuously monitor the connections of my work surface. So whether it be the ESD laminate or a soft mat, monitors, just so you know, they don't monitor the surface resistance. They monitor the connection between these 2 points. So if I, for some reason, lost my ground, it fell on the floor. Okay. Oh, sorry, I got my foot runners on stand. Hang on a second. I gotta hold this up. Okay. I was grounded to holding the mat.
That's actually a great demo.
I know, you think I know better. So anyway, that's the function of the what we call the mat or the work surface testing function. Henry?
All right. So next we're going to talk about, we touched on it earlier, right? But the 12-inch rule.
Yeah.
Okay. So when ESD sensitive device is being handled, we got to pay attention to what's nearby. It's easy to only focus on the circuit board or component, but the area around it also matters, right? So go ahead, you can switch it to the next one.
Yeah.
So talking about storage, shelving, carts, and racks. So storage is also, it's very commonly overlooked. How many times, Greg, do we walk into a facility and there's clear bins sitting there right next to the board?
A yellow bin, a blue bin, a red bin. Those are all non-conductive. They're not static dissipative. So again, the guy says, the young lady says, I got screws and bolts in there. Well, you saw with my demonstration here, our demonstration, isolated conductors are a big problem, just as that other static generating materials. So here's what you need to keep in mind, and that is how this thing's getting from point A to point B and is it unpackaged or is it properly packaged? So if it's in static shielding containers, static shielding bags like this, you're familiar with these metallized bags. If it's in a closed static shielding container, then I could carry this across the street if I want to. So when it's not, and you're going to say, take these components on a cart, that cart needs to be grounded as well when that's being transported, and it needs to be transported in, static dissipative conductive packaging materials. And if you ship it, especially, it has to go in a static shielded container. So you got to be thinking at all times, how is it getting from this point to the other point?
Exactly. Right.
And then once it gets there, can I ground this container once I set it on my work surface? Can I ground this bin cup? I take it off the cart, clip it on my rack. Is that going to be properly grounded?
That's right. And we touched on this earlier. If you can't, now we're going to talk about ionization. Okay, when is ionization needed? That is a common question that we also get from a lot of people. When do I need ionization?
So I talked a little bit about how it works. We're producing ions, we're producing both polarities, and positive neutralizes negative and vice versa. So that's one value of it. But there's other reasons for it too. One is, even if I'm wearing my ESD smock, if I had a charge on me, for example, even the ionization is neutralizing me. Our ionization is great for particulate control at your workstation. If you have a Treston bench in your clean room and you're producing things that might have particulate, or you're like the screen on this, the last thing we would want to do is ship you this board and it's got a whole bunch of dust all over your screen, or your brand new iPhone. So ionization helps control particulate. So there's multiple reasons to use that. But also this is one thing that a lot of people don't think about. It's not just about neutralizing the charge, it's about keeping that charge from being as great as it could be. So something that might be 5,000 volts like this paddle, maybe only charges up to a couple of hundred volts until it's completely neutralized.
That's right. The other question that Greg and I get often is, does positioning or type of ionizer, whether it's a bench top or an overhead that you see there and the one we hear, does that matter?
Right. So there's two requirements for ionization at the workstation. One is the offset balance. So we don't want to generate a static by having an ionizer that's out of balance. So there's a requirement that the ionizer, at the very minimum or maximum, not generating more than 35 volts plus or minus. So now we don't have a static generator. The second requirement is how fast it takes this ionizer to neutralize 1,000 volts to 100 volts. So now, again, it doesn't matter what it is. If you wanted to do it faster than whatever, but then say that guy building a military thing or that guy building, a toy, whatever it is, you want to establish the fastest discharge time that you possibly can. So this is what's called a portable charge plate monitor. So this monitors the balance of the ionizer, and then it also allows me to charge this plate up. And then it has a built-in timer so I can measure how fast it's knocking that charge down. Also, the performance of the ionizer is based on distance and fan speed. The higher the fan speed, the faster it is. The closer the ionizer is to a practical standpoint, that determines distance. So I'm just going to show you right now. The qualification distance is 12 inches for this ionizer, but that ionizer may be mounted all the way over here, and I'm working all the way over here. But just to show you, so what this thing's going to do, when I press the charge button, what it's going to do is going to charge it up that 100 volts. When it gets 1,000 volts, once it gets down to that point, then it's going to start counting. So you're not going to be able to see this right now, but I'm going to show you. It took 0.8 seconds to knock that down. That is super fast. Now I'm going to do it over here. Okay, so can you get it as turn it? There we go. Okay, so now I'm going to, can you see that screen? Okay, so you can see it's still counting, still counting, still counting. So what we want to make sure, I'm already up to 6 seconds. Now that's not a problem if I set my maximum discharge at 10 seconds, if that's all I need. So you just want to make sure you establish a maximum time that you can meet. The other thing is convenience. One of the convenient things about this is that arm. Now I can get it right down over my work, blow it, or I have an overhead ionizer that blow the ions down. Keep the air off of me, blow it on the product. So there are other factors to think about.
That's exactly right. So thanks, Greg. Appreciate
Yeah.
that. We're going to talk about bringing everything together. This is going to be the final portion of Greg and I's presentation. So when we bring all of these components together, the goal is not to add as many ESD products as possible. The goal is to build the right workstation for your application. The work surface, the grounding, the personnel grounding, the monitoring, storage, mats, ionization, verification of everything that supports the product being handled and the operator doing the work.
Correct. We have customers that have $50 PCBAs, and we have a customer that's got a $135,000 chip on there. So it all depends on what it is that you're making, how many of these things that you need. But most importantly is that we build it so it's reliable, and we build it so it's going to meet your compliance. So you can have some mats that might last a year, other mats that might last 20 years. I can't tell you how many times I've walked through a facility and the ground cord's laying on the floor. Are your personnel properly trained? Is everything secure on the workstation? Is that bin that's holding the bin rail? Is that properly dissipated or conductive? So when that operator takes that off, puts it back on, it's properly grounded again. So that's all on the compliance side, but that's all what a well-designed workstation is all about.
That's right. So Carissa, we're going to hand it back to you.
Great, thank you. So now I want to shift the conversation from the individual ESD controls to the workstation itself. Because the bench is not just a place to put mats or monitors, wrist straps, bins, and ionizers, the workstation has to support how those controls are used every day. And that's where the workstation design becomes really important. So Neil and Bill, I'd like to bring both of you into this part of the webinar. Neil, why don't you start us off from the Treston workstation design side of things?
Thanks, Carissa. Before we get into the details of workstation design, it's important to step back and ask a simple question. Why does the bench itself matter so much in the ESD control? The bench matters because this is where the operator, the product, the tools, the storage, and the grounding all come together. A customer can have the right ESD products, but if the workstation isn't designed around the actual work being done, being performed, and the setup can become cluttered. It can be confusing, difficult to maintain. At Treston, we start with the application. What's being built? What are they repairing, inspecting, or testing? How sensitive is the product? Where do parts enter into the workstation? Where do they go from there? Where do they go next? What tools need to be within reach, and what should stay away from the product? That's why workstation design matters. The bench has to support the process and not fight against it. The Concept Ergo workstation behind Carissa, shown on the slide also, it's a strong example of that. The steel frame, uprights, the shelving, and each of the steel accessories are finished with an electrically dissipative powder coat. That finish allows those steel components to become part of the workstation's overall grounding system. In practical terms, the frame, the uprights, shelves, and many of the accessories are designed to work together as one ESD protected structure. Customers don't need to individually ground every shelf, every upright, or every steel accessory that is part of that system. That creates a cleaner design. It reduces installation complexity and helps the workstation remain easier to inspect and maintain over time. This is also why we like to describe our approach as ESD proof by design. Our product developers intentionally design every workstation from the bench frame upward with ESD protection in mind, so that compliance is not added later, but built in from the very beginning. It's also important to understand that ESD grounding is not handled the same way on every workstation, even within the Treston offering. For example, on a Treston Workmaster ESD bench, ESD shelving is typically handled with ESD mats that include snaps and ground cords. That's still a valid ESD solution, but the grounding method is different. That's not true for every ESD bench design. That does not mean one approach is automatically right for every application. It means customers need to understand how each workstation platform is grounded. The key takeaway for this is the workstation design affects more than just the physical layout. It also affects how the workstation is grounded, how clean the setup looks, and how easy it is to maintain over time.
Hey, morning, afternoon, everybody. This is Bill Butt here. Like Greg and Henry, I'm INRD certified ESD specialist too. And so we're kind of talking about a little bit about what we see in the field like here too. And we'll talk a little bit about that more in just a minute as well. But between myself and certainly Greg and Henry, we've done hundreds and thousands of these ESD evaluations. And one of the things we note, and one of the things that makes a difference is this is kind of where Treston really stands out. From setting up your workstation, when we start with that grounded workstation a lot of times initially, but then the project changes or the scope of what we're doing changes and things get added and put on the workstation that are different than what we've done before. And that's where the Treston system becomes a little bit different. As the product changes, we can easily add things and make those ESD protective. So with the frame and the work surface and the shelving and the racks that are all ESD protective already, they're all dissipative materials. I can add a shelf automatically. I can set product on those shelves right away and know those things are protected. I can add bins like Greg and Henry talked about. I can add those onto the back and know that they're grounded. I don't have to scrape off any paints. Everything is already protected in a system. That's what makes this dramatically different. The large number of accessories that they have that support this are inherently ESD protective. So it's not a decision-making process for you or your employees when they place things down there. There's no labeling involved. I don't need to say this is not an ESD shelf. I mean, that's what we contend with a lot of times. We find out, and we'll talk about that in a minute, is the shelving isn't labeled, but people don't know that. They just put things down because it's at a ESD protected workstation. The shelving or the labeling gets ripped off. So those things happen, and this solution here solves a lot of those issues. There's no additional grounding. If I've got a shelf on an upper level, I don't now have to lay a mat on it, run a ground wire to it, tie that ground wire to the common ground point or common point ground, and make everything the same. So it eliminates a lot of that clutter, the wires and things like that. And it's a 2 to 3 minute change. I add a new shelf. It's just a slotted upright system. It's easy to do, easy to add. There's even these uprights that are ESD protective with these paints. If you don't have Treston benches now, and you might have IAC benches, or you might have brand X or brand Y benches, you can add these ESD protective uprights to your existing benches. We allow there's adapters to be able to do that. You're going to have to ground the uprights. But once you ground them, now everything within that system is going to be grounded. So a pretty useful tool, and again, a pretty big differentiator between what Treston offers versus what most of the market sees out there. And one last comment here, if you have an ESD laminate surface here, but you do want to add a mat on top of that, you simply can add, and this is a very common confusion point here, you can simply lay that mat on top of that ESD grounded laminate surface. I don't need to run a separate ground from that mat to a ground point. The standard in recent years has allowed us to do that too. So it gives you a lot of flexibility whether you're going to use laminate or mat, and you can just make the decision like this, and it's done in a matter of minutes. So go ahead, Neil.
Yeah. So products rarely stay in one place. They move around. They're handled on the work surface. Sometimes they're staged on a shelf. They're placed in a bin, moved to a cart, maybe on an accessory shelf while the operator works through the process. That's why the workstation has to provide the right places for parts and tools and materials. With a properly designed ESD workstation system, shelves, bin rails, ESD bins, your monitor arms, tool holders, accessory rails. They can all be positioned around the operator in the process. Using vertical space in this way frees up the immediate workspace while still keeping the necessary tools and the components within easy reach of the operator. The whole goal is not just to ground one surface. The goal is to design the whole work area so the product has a proper place to be throughout the workflow.
Yeah, that's right. So a little bit like what we talked about in the last slide, we don't want to we want to eliminate that decision-making process from the operator, right? We don't want to allow them to have to decide what is ESD protective, what is not ESD protective, and where things are going. So when we tie everything together here, that eliminates that concern that we have. And that's not intentional. Operators don't intentionally try to place things on surface. I think we've all been in a hurry and in a rush when we walk somewhere and we place something down and it's not protecting and we think it's okay. But the reality is it may not be okay. So when we get these surfaces, these uprights, these carts together, we've kind of created a culture here, and we've got to created a culture where we don't have to live in that. And you get buy-in in that culture too. Once you get these things rolling, operators and supervisors begin to buy into the culture, and it becomes a self-policing culture. Once you get that done, you'll get some resistance at first, but generally speaking, we get that buy into that culture. And one of the other things too, when you see these upright systems here, you see this is a traditional bench. Let's say this is a 72-inch or a 60-inch bench here. It's a divided upright system. Now what we can do, let's say next to that monitor that you have on this slide here, maybe I can't put a bench, or maybe I can't put that monitor off to the side because I've got another bench butted up to it or right next to it, adjacent to it. This system allows you to put that monitor towards the middle, and now that shelving can be above it. It's not one shelf that goes across the entire surface that has to be at the high level above that monitor. It's a shelf. Now I can, in that next bay to the right, I can maybe move that shelf down lower. So now we've created a ergonomic access point. And with these benches, what you see is by going up and using some of these accessories, you can even see a soldering iron stand in that one picture, just above some of the black items on the work surface there above his hand. I can reduce my workspace. So I've had 3 facilities in the last 2 months, and one of them has gained about 20 to 30% additional floor space by reducing their bench size. Instead of a 72-inch bench, because they needed all this space for their test gear and for soldering irons, for storing, they've managed to go up. So if you can gain 20 to 30% of your floor space back by reducing your bench size and working up, kind of like what we do with vertical carousels or vertical storage systems, we've got a win here. We can gain 20% more workforce on the floor. We might be able to eliminate a second shift. Generally, those are smaller shifts. We might be able to do that and move it down to our first shift, where a little more productivity occurs in that single shift, or the first shift, I should say. So a lot of big advantages to these bay systems, these grounded uprights, allowing you to move upward with products, processes, tools. And you can even see here, this is a dual bay system, but there's triple and even quadruple bay systems. So there's a lot of flexibility there. So back to you, Neil.
Yeah. So that brings us back to the 12-inch rule that Greg and Henry spoke about earlier. From a workstation design standpoint, the 12-inch zone is where the layout becomes very practical. If the operator needs parts, tools, instructions, packaging, and any other equipment nearby, but the workstation doesn't give those items a proper place, the main work surface gets crowded really quickly. That creates risk. Good workstation design helps keep the protected zone under control. Shelves, bin rails, ESD bins, monitor arms, tool holders, accessory rails, that helps move items off the primary surface while keeping them organized and within reach. And the goal is simple. We want to make the correct behavior for the operator as easy as possible.
Yeah, that's right. I mean, so if we've created the right workspace, we've kind of right-sized the workstation. We haven't gone too big. We said, hey, maybe 72 inches is too big. We don't need it. Maybe it's 60. Maybe it's 48. Maybe it's not 36 inches deep. Maybe it's only 30 inches deep. A lot of flexibility in that. And that kind of goes back to what we just talked about on the last slide there. When we go up, we allow the workspace to be unencumbered by those items that might be detrimental to our ESD sensitive items. You know, Desco and SCS will gladly sell you ionization for your workstation, but they want to make sure that they're selling the ionization for the right purposes. If it's just because we have a cluttered workstation, well, we can solve that a little easier by just going up and off of the workstation and eliminating some of those things, and create quite honestly, an ergonomic workspace for the operator. Obviously, efficiencies and things like that. So once again, we kind of eliminate some of that decision-making process for an operator when we do these things, and everything is protected and up and out of the way. I like to use the analogy when we talk about these things is a seatbelt. If you drove into the office today or work today, did you wear your seatbelt? Probably 99% of you are going to say yes. And I'll say, do you remember putting that on? You're probably going to say no, because I don't. It's an automatic system. So once you create automatic systems like putting on your wrist strap when you sit down, they don't get to make that decision no matter what they do. They're not making that decision about what is ESD sensitive, what is not ESD sensitive. Same thing with the shelving and the uprights. We just create that space. And so now they know where they put things. It's 12 inches away from where they are, and it's protective and safe at that point. Go ahead.
Yeah. Ionization that he was talking about, that's another example of designing around a process. If an application requires ionization, the question from a workstation design standpoint is, where does it go and how do you keep it from interfering with the operator or technician? Work surface space is valuable. Just like we were discussing earlier, the more equipment you place directly on the surface, the less room the operator has to work. Treston workstations, overhead ionizers can be mounted using a light balance rail because our slided upright system allows the rail to be fully adjustable up and down the uprights. The ionizer can be positioned at the correct height and location for effective coverage of the work area. That flexibility is important because ionization only works properly when it's placed where it can actually reach the product and the technician's workflow. In addition to overhead mounting, we can offer arm brackets that allow benchtop ionizers to be mounted off the work surface. You saw one earlier that Henry and Greg had on the set on the bench that was by them. It was an arm that was attached to the edge of the work surface, but that could be mounted in a bracket on an upright. Even though we don't have a benchtop ionizer in the showroom, I wanted to point that out just because of that. That's a common configuration that customers do, where users want ionization at bench level without sacrificing valuable workspace. Both approaches help keep the workstation cleaner and more organized because the ionizer is not taking up room where the technician needs to be handling the product, his tools or her tools, and any components. The point is that the workstation should be flexible in ways to position ESD controls where they're effective while still keeping the work area clean and usable and the operator's workflow moving easily.
And I'm actually going to pause you guys for just 1 second. We're getting a little close on time. We're going to continue, but if you need to jump off, that's fine. We'll have the recording sent to you in the webinar email after. So we'll continue, but feel free to stay on with us.
Yeah, just quick comment on there. That placement of those ionizers is going to be key. Shadowing with other items on the work surface makes them less effective. And so with these upright mounting systems, whether it's in the arm system or an overhead ionizer, we're able to mount these to the proper height so we get the proper dissipation rate, as Greg showed you and Henry showed you during that. We want to be able to get that so that charge is dissipated quickly.
Yeah, so the final point I'd like to make is that ergonomics and ESD are connected more than most people realize. They move parts closer than they should. They ignore storage locations. They may work around monitors or even reposition tools because the setup doesn't support the tasks that they're doing. That usually doesn't happen because operators don't care about ESD. It happens because the workstation makes the correct process harder than it really needs to be. A properly designed workstation puts frequently used items within easy reach of the technician. It supports seated or standing work, positions tools, monitors correctly, and keeps the primary work area clear. That makes it easier for the operators to follow the ESD procedures consistently. That way it can become a habit, just like he was talking, like Bill was talking about with, putting your seatbelt on. It's sort of ingrained in you, so you do it automatically.
Yeah, without even knowing it, most of the time, we see that ergonomics are a huge part of what we really already discussed. Most major organizations have industrial engineers or efficiency experts that work to find these exact solutions, the things that we're presenting here today to make things that increases throughput, making pick points closer, to help the workstations more organized, so there's not, again, a lot of fumbling around or trying to find what we're doing. And quite honestly, study after study shows that operator fatigue increases throughout the day. And so when we've made that a much more efficient process, we eliminate those last 2 hours of the day where the efficiency of the operators begins to slide here. So that's part of what we're trying to do. And the other thing that happens is we get operator retention and operator longevity here when we've got a clean, easy to use, a friendly workspace. We know that studies show that operators tend to stay more with a company like that when they have attention to the operator themselves as well.
Yeah, absolutely. So thank you both for that overview of workstation design. Bill, the last thing I want to bring up is, can you give us an overview of maybe some of the common ESD workstation setup mistakes that you see and some of the best practices customers should keep in mind in the field?
Sure. Yeah. One of the things that we see a lot out there, and we're going to quickly just hit these topics here. Some of these things are going to be fairly obvious, but we talked about this here. If your ESD mat is too small for your work surface, especially if you don't have an ESD laminate underneath that, that's just going to give you a chance to put products outside of the ESD protected work surface on a laminate where it remains ungrounded. The possibility is those devices charge up, and like Greg and Henry talked about, we want to give these items, these devices, these ESD sensitive devices, a chance to be grounded on here, because when we build up charges as they relayed, a charged device is much more likely to damage the device than even the human body model, where we lock up and induce a charge on something like that, and it becomes a little more costly. So we want to take care of that. Protective racks on the ESD, on non-ESD surfaces. This goes back to the same thing. If we've grounded our upright and we have everything at the same potential, we can clip ESD bins onto the upright system and have everything in a safe place. We see this very often where things are placed onto uprights. The operators don't even think about it. They're not grounded. Now we've created an issue with a ungrounded ESD sensitive component, device, circuit board, whatever it might be. So very common. Another common thing we've seen this seems to be a little less prevalent than it used to be, but daisy chaining, that is chaining one mat to the next mat to the next mat, or one workstation to the next one to the next one. Definitely want to eliminate that. You're going to you potentially have a high impedance situation, but you don't want to, when you lose a ground, or if you lose a ground, we don't want to lose a ground for all our workstations too. And there's some other good reasons behind that too, but in generally, that's a good thing. And then one last thing, the guys already talked about this, bins. Color your bins. If your bin is not generally speaking, if it's not a black bin, it's probably not an ESD protective bin. The caveat to that is not every black bin is an ESD protective bin. So you do want to test these. You do want to verify when you purchase them. Don't just assume that a black bin is a safe or an ESD protective bin. So next. Another important feature thing here, another important thing we need to do is we need to verify. So a required test is actually the surface to ground test. The which is the RTG, or the RTT, the point-to-point test, is not a required test, but it's something to help you do troubleshooting. Matte materials are going to go bad over time. There is no question. If you use a lot of alcohols on them or solvents on them, that's going to accelerate the degradation of that mat. We do need to verify that those mats are properly grounded. And if we get improper readings, then we need to verify that the surface of the mat is actually still good. It's kind of something you can check, but if a mat feels kind of crunchy and rigid, there's a good chance you're starting to lose the ESD characteristics of it. That's not the only indicator, but it is one indicator of it. One of the ways we can monitor that grounding system there too is the continuous monitors that Greg and Henry talked about. And that is a full-time continuous monitor. It's going to monitor to make sure that mat is grounded, obviously the operator as well. So if that ever does get knocked off, the grounding point, if you are using a mat or something else, you'll immediately know when that happens. Not 6 months later when you test the workstation, which is a very common thing that we see out there. You slide a rack back, it pops off the snap on the back of the mat, and nobody knows until 3, 4, 6 months later, and when you're testing the ground of the mat. And then one last thing. This may seem again obvious, but make it obvious. So color code your workstations, label your workstations, label your bins, your carts. Blue mat's a great example. Blue mat indicates an ESD protective workstation, or a green mat if you've got a lead-free system. And then the mats, or the workstations that don't have mats, operators should understand that's not an ESD protected workstation. If you've got grounded and ungrounded blue mats throughout your facility, that's going to create issues where people think they've got a protective surface and they don't. So that's a very obvious one, but very common to find that issue.
All right. Well, thank you, Bill. Before we move into the Q&A, let's quickly recap just a few key takeaways from today's discussion. So first, ESD control is a system. No single product can protect the full process on its own, so each part of the ESD program needs to work together. Second, the needs of the workflow should drive the workstation design. The right solution should be based on the product being handled, the process being performed, and the level of risk involved. Third, the workstation should protect the product and support the worker. So when the workstation is designed around how people actually work, ESD procedures become easier to follow consistently. Fourth, the small details are where ESD gaps happen. Overlooked surfaces, storage areas, grounding paths, or nearby materials can create risk even when the main workstation looks compliant. And then finally, a compliant setup still needs to be tested, verified, and maintained. ESD protection should never be assumed indefinitely because programs only stay effective when they are checked and maintained over time. So now we would love to hear from everyone here. Please submit your questions in the Q&A if you haven't done so, and we'll answer as many as we can get to. I know we're a little bit over time, but we'll see what we can get to. I know we did have a couple questions already that I've been responding to kind of as we go. But here's one question we got in the chat. How can you check or audit if there is ESD protection in the lab on a daily basis? Bill, do you want to take that one?
Yeah, sure. I mean, from a daily basis, our primary, one of our primary things we're doing is grounding the operator. So the operator ground is going to be something that you're going to have to test on a daily basis, whether it's the wrist strap or it's the foot grounder system. But if you want to do daily ground, if your product if you've got a product of high quality, high value, high reliability, to be able to monitor that, you would set up continuous monitoring systems on the workstations to make sure that the workstation remains grounded throughout the day, throughout the month, throughout the week and year.
Great, thank you. So I think that's all we have time for today. If you have any other questions, though, you can feel free to send them to us and we will get to them later. But thank you again, Greg, Henry, Neil, and Bill, and thank you to everyone who joined us. You can also find additional resources on our website, including webinars, ebooks, and white papers around ESD grounding and measuring. And then watch for an email with the recording of today's webinar. We'll be sending that out shortly. But thank you for joining us and have a great day, everyone.
Thank you.
Thank you.